Good afternoon, everyone, and welcome to the Mapei Academy. Today's presentation is going to be on swimming pools. We're going to talk about the waterproofing system and the tiling system, so just how we deal with it all. So swimming pools are great projects to win. We've certainly done hundreds of them now around the country, everything from many private swimming pools to again, many hundreds of commercial swimming pools from the Olympic pools. So we did Melbourne Aquatic Centre, we did Sydney Homebush. We've certainly done a hell of a lot of resorts pools. We just finished supposedly one of the largest pools in Australia is the Daydream Island pool. So we've certainly done some beautiful and some really good functioning pools around the country. We've done them in plenty of high-rise buildings. We've got them up as high as level 71 in the Prima Pearl Tower. It might even be higher than that. We're doing some presently in the Ritz Hotel in Melbourne, and levels 9, level 56. We're doing one as well. So we've certainly been involved in mini pools and some very high. On some high levels of some big buildings. So we're certainly well and truly used to talking about this type of stuff. So if you do the pools wrong, there's certainly some big consequences to face. So not so bad in a backyard pool, but you can see this example here where the pool was done incorrectly in a high-rise or rooftop pool on the Gold Coast, and flooded down 6 floors below. So many of the places were uninhabitable for the time being. So you can imagine the cost or the ramifications of having something go wrong. You can imagine the ramifications even for us that we've been involved in, casino pools and hotel pools, or even residential towers. So if they go wrong, there can be certainly massive prices to pay. We're going to cover off today the waterproofing system. Then we're going to go into the tiling system or the tile adhesives. We'll talk about the grouts. We'll talk about the sealants that are used, the flexible sealants. And then we'll cover off just 4 little special topics that we thought were relevant to this series. So we'll start off with the waterproofing system. So the aim of the waterproofing layer is, of course, to prevent water from escaping from the pool. It prevents water from getting into the shell, where it can affect or corrode the steel structure. And it also can be put into place just for an efflorescence control as well. So we'll talk about today in this area, we're going to talk about the substrate preparation, the treatment of junctions and joints, the treatments of penetrations, and then the application of the membrane itself. So in preparing the substrate, the concrete must be sound and well cured. There is various thoughts on the curing time of concrete. We work on the normal standard is 28-day cure time, but it does alter when we are talking about the big commercial pools, so like the 50-metre pools and so on. So there is a variation. It can be 54 days for external pools and 72 days for the internal pool. Sorry, the other way around, 54 for internal and 72 for external. So, but we mainly work on the, as I say, the average of 28 days. The preparation of a new swimming pool is obviously different to the preparation of an existing. So, but we remove all sharp edges or any kind of protrusions that's going to alter the thickness of the membrane itself. So any rough concrete, concrete debris, anything where the membrane looks like it's going to have to go up and over, we certainly want to get rid of it. So high pressure water jet to remove any surface slatants and also to provide the profile that we're after. And then the area should be made clean and dust free, especially when grinding has taken place. It's extremely important to make sure that you got the area dust free, because grinding can fill the pores of the concrete with a layer of dust. So we would patch holes and smooth the substrate to allow for that uniform thickness of the membrane, as we said. So we don't want to go up and over anything that's sharp, but we just don't want to go up and over anything anyway, because it alters the thickness of the membrane. So where the membrane's transitioning on a flat surface, then has to go up and over, say, a lump of concrete or any other type of area where it's dipping down. So if the if the existing tiles have been jackhammered off, in particular in the domestic scene, most pools are sprayed, so they're quite often quite an open surface that we're dealing with. So the membrane, while it can go in and out and up and down and all over, but it does alter the actual thickness of the product itself. So it's best to have a nice, smooth, plain surface to actually deal with. So we would smooth off with, we've got various different types of products. I mean, it can be done with the sand cement render, of course, but in the bagged form, we have a product, Planitop Smooth and Repair, or the Planitop Fast 30. But yeah, the area should be as smooth as possible, and it's certainly a lot cheaper to use a smoothing compound than it is to try and bulk out an area with membrane itself. When it comes to the floors, if we need to create a flat floor, quite often renders and or screeds are put into place to make the pool itself fit, or to have the tiles be able to be placed without too many cuts. Especially when they're using glass mosaics, it's a good idea to have the pool worked out, as close as possible to getting a full tile in all areas, so that we don't have any sharp edges of glass mosaics or anything like that. And any form of tiles can be sharp. So we have our engineered screeds. So again, a bagged product, factory blended. We have the rapid setting version of Mapei Pronto, and then our normal setting version of the Top Chem Pronto. So we would render with the Smooth and Repair. We screed with these Mapei or the Top Chem Prontos. The beauty of these products, as I said, they are factory blended, so that we know we're getting a uniform blend every single time. So a lot of the times with site blended renders and screeds, we're dealing with variation. So there can be a lot of variations, apart from the fact that a traditional sand and cement screed or render finishes or dries up at around about anywhere between 12 and 15 MPa. With our pre-blended products, we can be anywhere from 21 up to 50 MPa, depending on the product that you're actually using. So it's a stronger and safer recommendation to use the factory blended products, but pools have been rendered and screeded with sand and cement for many, many years. So the junction, preparation of the junctions, we're going to go through three options, two more important than the other, but we'll cover off the first one. So preparing the junction between the floor and wall, or the wall and wall. We recommend, especially for tiling scenarios, in most cases we want to have a nice 90-degree angle still, so that we don't have to use any form of fillet. So to create a rounded corner or a rounded bottom edge, we can just use our tape called Mapei Band Easy. It's a felt tape, and it can be moulded and forced into the corners to keep that 90-degree angle nice and tight. The other option, I'll go through what happens a bit later, but the other option is the traditional, so using a polyurethane to create a cove fillet. That cove fillet should be around about the radius of a 5-cent coin, so it's normally around 12 millimeters up and down. And then we would always put a fabric or some form of mesh into the first layer of membrane covering that junction, so we've got that bond breaker scenario going on. So as I said, these are the traditional way, but in a lot of cases when we're using a mosaic, either a ceramic or a glass, we need a tighter corner. So we've now, into the modern times, we've got the felt type tape that I talked about, that we can create a nice 90-degree angle. But this method is still very much used, and when they're using a ceramic tile, so the traditional pool tiles, they don't have to worry so much about getting tight into that corner. The third option is really to create a cove with a cementitious product. So that Plenty Top Smooth and Repair that we mentioned before, or we can go into our construction grouts, so the Mapei grout T40. So this is ideal when they are using a mosaic and they don't want to have that tight look, the 90-degree look where they want to actually cove the corner. And it also helps the membrane to transition more nicely into that corner. It doesn't have to change direction as such. So the felt tape that we talked about, the Mapei Band Easy, we also use it into dealing with movement joints. So the less problematic joints are just the saw cut joints. We would use the Mapei Band Easy. It's bonded into place by using the membrane that we're actually using to membrane the swimming pool. So that membrane is applied onto the structure. The tape is, or the felt is pushed into the membrane, and then we membrane back over the top of it as well. So it's sandwiched in between two layers of membrane. One advantage or beauty of this particular product is that it has a line that's manufactured into the product that runs down the center. So it's a good idea to line that particular line up with the saw cut itself, and leave it exposed. So the way it is in that picture, now we know exactly where that saw cut is, and so we can mirror that up into the tile work itself. And it actually should be done. You shouldn't be bridging control joints or saw cuts in any way. They should always be mirrored up into the tile work itself. Structural joints are a different thing altogether. They're a much more final joint. They allow for the whole structure to move. We deal with them in a different way. We use what we call a gasket type tape. So you can see it in that picture there. It's called Mapei Band TPE. It has a center made out of basically a plastic, and it's very flexible, but we also loop it down into the movement joint itself, and it's locked into place with the Diesel X PG4 or an epoxy adhesive that you can see in that picture. So in dealing with that, we prepare the joint, make sure it's nice and clean, free of any rigid debris, because we don't want to have, there's no use doing all the detailing above the joint and actually having the joint full of rigid debris, and it's not going to move and act the way it should act anyway. So it should be nice and clean. We put the epoxy down onto the substrate. Then we place the TPE or the bandage into the epoxy. There's felt on either side. Now, depending on the movement that's anticipated or expected, we loop the center down into the construction joint itself. So the center is the center of this tape is actually waterproof in itself, so we don't have to worry about dealing with it, but it has got to control or deal with the movement that's going to take place. So normally, as a rule of thumb, whenever I'm talking about it, I always recommend that the loop in the center is twice the expected movement that's expected. So in other words, if we're dealing with a pool that's set on springs and we're expecting it to, once we fill it up with water, it's going to drop 8 millimeters, I would expect that TPE would be looped down into that joint around 16 millimeters. So that it's never at tension. So that if the joint wants to open up, or the joint or the pool and the structure want to move independently, it's never actually stressing that tape itself. So then we would put the epoxy over the top of it again. So similar to what we talked about with the felt tape, where we sandwich it between the two products. So in this case, the epoxy, the PG4, and then we would sand seed the epoxy so that we create a nice keyable finish. So we just sweep off the excess and you'll end up with a nice sandpapery type finish that's going to be nice and easy for the membrane to bond to and or the adhesive to bond to. So when it comes to treating pipes or any forms of penetrations in the swimming pool, this is the major area of where leaks occur. So it's very rare that we have any leaking issues into the center of the pool or in walls or anything like that. Most often when we are called into a job to try and work out where a pool is leaking from, we lower it in stages, and we get it down to A penetration, and so on and so on. But normally, when we get it to A penetration, so like the skimmer box or the jet pipes or the in and outtake pipes, or the lights in particular, that's normally where we find it. So we'll talk about how we would retrofit them or fix them later, but we'll talk about now how we actually deal with it. So it's not good enough to just run the membrane up to the penetration itself. So we find that a lot, especially in domestic situations. They don't really understand the necessity of making the surround of the penetration waterproof before they actually apply the membrane. So there's a lot of vibration and movement that takes place in these pipes, especially with the infills and also from the suction. So the water going through the pipe creates a fair bit of vibration. There's also the thermal expansion and contraction that takes place of both the structure and or variations in water temperature. So in other words, people having their heating on, their solar heating on right through summer, and then they just turn it off at the end of summer, and then at winter we get a big drop of the temperature, or vice versa when they come to use their pool for the first time out of winter and they heat it up at a rapid rate. So there is that movement that's going to take place. So it's not good enough to just run the membrane up to it, but it's also not good enough to just put a bead of sealant. So, we find a lot of people just, literally think, I'll just put a bead of silicone or a bead of polyurethane around the pipe before I apply the membrane, and that's going to do the job. It's not. I mean, the polyurethanes in its exposed environment like that actually have a very short lifespan. But again, the bond to PVC is quite difficult, and it's just, the polyurethanes and silicones just aren't up to it by themselves. So we certainly would never rely on just the membrane nor a bead of sealant around the penetrations. So we'll show you a couple of different treatments that we prefer. There is a stock standard that takes place in the industry, but we'll talk about the ones that we actually prefer. So our preferred is to use something like a swellable product, basically. So the Mapei Proof Swell, in this case, it's a single component polyurethane that swells when it comes into contact with water. So as it swells, it creates even a tighter seal than what we're even going to create with just applying the product itself. So to treat this penetration itself, if it's not cast in, so a lot of the commercial pools already have the pipes cast in, and especially in the floor penetrations, they leave that 80 mil or 60 mil depth around the pipe. It normally gets missed in the walls, but in the floors, it's pretty much always there. So, the pool builders should actually understand that they need to cater for this when they are forming up the pool. So, the best way to do it is to literally put foam around the pipe, and that foam can be removed later on. So, as I said, and if we were doing a retrofit fit or fix, we would have to break the concrete away to actually get back to create a seal around the pipe. But because of the nature of this particular product, that it does swell when it meets the water, it does need to have a certain amount of cover of a construction grout over the top of it. So 60 mil is the normal depth that we talk about. We would gun the swell into place. Then we would prepare the pipe. So we would abrade the pipe, give it a light sand, and then we would prime the pipe with an epoxy, and best to sand seed that epoxy as well. So you literally paint the epoxy on and rub the sand around the pipe just to leave that sandpaper type finish. And then we fill the area with some form of grout or a repair mortar. So the Planetop Smooth and Repair. So we've already used that product in the patching up of the shell itself. And then when we bring the membrane up into that area, like in any form of application of a waterproofing membrane, I believe that you should, wherever something meets something, we should reinforce the membrane. So we would put a fabric or a netting into the membrane. So the Mapei Texel or the Mapei Net 150 into the first layer of the membrane. The second option is probably more commonly used, where we actually, there's a smaller void around the actual pipe itself. So a lot of people just do the finger, so a 10 mil gap between the, around, or indentation into the concrete around the pipe. But it should actually be bigger if you do actually get the chance to set it into the casting situation. So we do recommend it to get back to around 30 millimetres deep and around 50 millimetres wide. So what that offers us is, one, is strength in the epoxy, and two, a bigger area that we can actually lap the membrane onto the epoxy itself. Again, we would abrade the pipe, and then we would spatula or force the epoxy into the area so it's nice and compact and creating a really nice seal around the pipe itself. And then we bring the membrane up onto the epoxy, as I said, and then it becomes a junction. So like I said, where something meets something, we would reinforce the membrane with either a fabric or a netting. Then it comes to the actual application of the membrane. Our go-to membrane for swimming pools is without doubt the Mapei Smart. We have literally, Mapei Smart's been in Australia for about 21, 22 years, and we have literally done hundreds of swimming pools, as I said, from commercial to high-rise to public to private, you name them, we've done them. So it's got a really extensive track record. My own swimming pool is certainly waterproof with Mapei Smart. It's a highly flexible product. It's got long-term barrier performance, so we use it in all sorts of scenarios, even in potable tanks. So you can see there it has been approved for potable. Not that we drink pool water, of course, but it does get used in those scenarios. So it's got excellent resistance to pool chemicals, and it's got that crack bridging ability. So always apply a minimum of 2 coats. There is just no two ways about it. We have many people over the years come to me and tell me how they can, they love the product because they can do it in one application. It's never acceptable. 2 coats is always what should be applied, for reasons being that there's always pinholes in the first coat of membrane. I'll go into it in a little while, but if we get a magnifying glass out and look at a first layer, there's always little pinholes into it, and it is hard to get the exact required thickness that we actually want. So we want the required thickness because it gives it makes the membrane function the way that it's actually been designed to. So a cement-based product should be a minimum of 2 millimetres thick. Always follow the drying times. It's the other thing that we get put to us a lot. Can I go over it while it's semi-dry? No. So can I go, start applying membrane if I finish one end and go back to the other? No. You got to wait for it to dry properly. Normally, on a normal scenario, it normally takes around 3 hours to dry the first coat, and then we would go back and follow it up with the subsequent coats. So as I said, always apply 2 coats. So when the first coat goes down, it's still allowing vapor to transfer through the first coat, air traveling through the first coat, but vapor in particular will create pinholes. If the surface preparation is not done perfectly, if there's any dust, then pinholes can form. There's no doubt about that. So the second coat reduces the chances of the pinholes, and it also, as I said, creates the true film thickness that we require. It's recommended to reinforce the first coat of the Mapei membrane with either Mapei Net 150 or the Mapei Tech Cell. It's recommended, it's not compulsory. We don't do it in all swimming pools. We certainly highly recommend it in high-rise swimming pools where we're expecting movement of the building. We also highly recommend it in some of the larger public swimming pools where they're subject to a lot of exposure, sun exposure. So we're dealing with that thermal expansion and contraction. So the membrane not only does what we talked about before, stopping the water from going anywhere, stopping the corrosion, efflorescence barrier, but the membrane can also act as, basically like a skin. So a bit of a bridge between the adhesive and the substrate itself. So it just allows for, a little bit of extra movement. So it's not what we rely on, but if it is in place, it does allow for that extra movement. The reason we talk about the Mapei Net 150 or the Mapei Texel is that it strengthens the membrane dramatically. So as much as I love Mapelastic Smart, it's one of my favourite products out of the 5,000 products that Mapei have, and mainly due to the fact that here in Australia we were involved in the I'll call it involved in the recommendations of a bit of an altering of its mother, the Mapelastic, where we changed the ratios a little bit. Instead of being a 3-to-1, 3 powder, 1 liquid, the Mapelastic Smart is the 2 powder, 1 liquid. Sorry, so it's a bit more flowable as such. So I love the product dearly. But, without the fabric in it, even at 2 millimeters, I can grab it in my fingers and pull it apart. It'll stretch and stretch until eventually it breaks, But if we've got the addition of the Mapei Net or the Mapei Tex, you can pull and tear on it as much as you like and you're not going to pull it apart. So, I firmly believe in strengthening membranes. A lot of people talk about it loses its flexibility, but the reality is it's over a rigid substrate with something rigid going over it. So what we want it to actually be is strong. So hence why I said we would always put a fabric or a netting where something meets something. So because that's in critical areas around pipes or at junctions, floor, wall, we strengthen the membrane. But, in my opinion, to put the mesh right throughout the whole layer of the membrane just gives you one big, long, strong membrane itself. So it could actually detach and still stay in place. I've seen it many times where it's detached because of lack of substrate preparation, but they still couldn't get it up because it was just, locked in with the mesh itself. So applying the correct thickness, it is written on the data sheet that we should be at least 2 millimeters. There's just no two ways about the fact that, these, people that are a hell of a lot smarter than me develop these products. As I say, we just gave an idea, but the development of the product is done by the chemists, and they make it to go in at a certain film thickness so it performs the way that it should perform in accordance to the data sheet. So the continuous film thickness or the continuous film is probably the most important aspect, but for it to function the way we want it to function, we do require it to be at the required film thickness. So the consumption of the Mapelastic Smart is around 1.6 kilograms per square meter per millimeter of thickness. This can be measured with in a wet film, so in its initial stages by using a wet film gauge. If you haven't seen one of these before, it's got teeth on the gauge. It's pushed into the membrane, and when you have a look at the teeth, when you pull it up, the last tooth that's got membrane on it has got a marking on it, which will let you know the thickness that you've actually got to. So it's it's commonly used, not commonly enough as far as I'm concerned, but it is commonly used. The one beauty of using that Mapei Net or the Mapelastic Mapei Texel is that we actually, we create film thickness because we're putting something in there that needs to be hidden. So if we walk onto the job and we can still see the fabric, we know they haven't got the required film thickness. So of course, the other way to test the film thickness is to do the dry film thickness. So literally where a square or a piece of the membrane is cut out and then measured with some vernier calipers. So, but a wet film gauge is a nice simple way to actually work out if you're doing the correct thickness in the process as you're going. So then it can actually be altered while you're going, because once it's dry, it means you've got to do another coat. But if it's still in the wet state, it just means you might need to add some more product. So the recoat and dry times, as I said, they're there for a reason. The first coat will allow that vapor transfer. The second coat stops that, or will still allow that vapor transfer to happen from the first coat. So once the second coat goes on, it stops. So this is a really unique property of this particular product, and it's certainly not so much in the swimming pools, but just in construction itself. We do keep a lot of projects actually going in the rainy or the colder months by having the ability for Mapelastic to go on to a damp or moist substrate. So, but yeah, the two coats is I can't stress it enough. So the dry times that we talked about, as I said, these products are developed in a lab. The guys that are in there, or the people that are in these labs, they stay in areas that are always kept at a constant 23 degrees and a 50% relative humidity. So the drying times can alter when we're out in the real world. So when we're in a windy area, for instance, or lower temperatures, and I don't just mean the air temperature, I mean the structural temperature. Sometimes the air temperature or the ambient temperature can be 10 or 15 degrees, but the structure itself might be still at 6 or 7 degrees. So, we've had plenty of phone calls where they've said, oh, I've put Mapelastic Smart onto my pool shell and it hasn't dried up in the 3 hours, and I say, well, have a look outside, it's 5 degrees, so give it a chance, So as I say, those dry times are based on 23 degrees and 50% humidity, so they will vary depending on the conditions that you're actually working in. So in the scum gutter, we step away from the Mapelastic Smart if it's not going to be tiled. So in a scum gutter where the membrane is going to be left exposed, we step into a product called PlaniSeal 88. A lot of people would have known this product as Hydrosilex Pronto. Again, it's been used for well over 20 years. We always use this where we have areas that require a higher wear resistance. So in other words, with the water that's constantly flying around the scum gutters, and remember, it could be hot water, it can be, it's got chemicals in it, it might be salt water, it could be all sorts of different types of water. But we just would always step into the PlaniSeal 88 or the Hydrosilex Pronto. So again, I think a minimum of 3 coats, but we do want to achieve that 2 to 3 millimetre final thickness. I always say to people that 2 coats is probably, well, it's not probably, is going to be enough, but the third coat is just the protection coat, so it acts as the wearing layer itself. So I always recommend in those exposed areas to step up into a 3-coat application. So we'll step away from the waterproofing system. Don't forget, if there are any questions, you can write them. There's an area where you can write your questions, and also I'll give you my details at the end. So we'll go out of the waterproofing system that's pretty complicated in some aspects, and we'll step into the other areas. So into the tile adhesives. So in accordance with the Australian standards 3958.1, we need to use an adhesive that is at least a C2S1. So I've done webinars before on adhesive types, and those letters and numbers, what we call the classifications of the adhesive. So in this particular case, the C is a cement-based product. The 2 means it's a modified cement-based product. So in other words, it's a much stronger or highly modified blend of the cement. The S is for the deformability, the ability for the movement to take place. There's S1 and S2, so a minimum of C2S1. So as I said, the C2, the modified cement provides a sufficient strength in an immersed situation. And the S, the deformability of the adhesive, offers resistance to pool stresses, which we'll talk about a bit further when we talk about movement joints and so on. And it also improves the adhesion of the product. So, a pool is a harsh environment, constantly immersed. And as I said, talking about different temperature fluctuations, exposed, You know, in a public swimming pool, for instance, there's hundreds of people in and out of them. So they're in a harsh environment. So we just need to make sure that people understand that we always recommend a minimum of a C2, S1. Those classifications, if you did miss that webinar, those classifications are on the bag, and they should be on every reputable adhesive company's bag, and they should actually state what's truly in the bag. So look for that symbol on the bag. So in our range, in the regular setting products, we have the Keraflex Maxi, Ultralight, and the Kerabond Plus liquid, the latex isolastic. And then into the rapid setting environments or products, we would go to KeraQuick or KeraQuick plus Latex Plus. So I always recommend and talk to a lot of pool tilers or pool builders about the use of a rapid set product, you know, at a minimum to do your stairs and the floor of the pool. So, you know, we are dealing with tiles in swimming pools that have a low absorption rate, you know, in particular glass mosaics, for instance, that have no absorption at all. So the adhesive can't dry by having the water come out of it via the tile. And in most cases, we've got the waterproof membrane. So it's not, you know, it's sitting between something that's non-porous and sitting on something that's non-porous. So the drying times can be prolonged, so greater than what's actually specified on the bags or on the data sheets. So I always recommend for people to use the rapid sets to do the steps and the pool floors, so that they know when they have laid those areas and they come back to traffic those areas the following day, the adhesive, being a rapid set, is at roughly or close to full strength after 6 hours. So it's not quite at full strength, but it's certainly at a much higher strength after 6 hours than what a regular setting product is. So what happens if the adhesive is not dry? They can traffic the areas and create, you know, detachment or, you know, debonding of the tiles. So in a lot of cases, it's actually not picked up because it's such a slight detachment. And, you know, the grouting takes place and then they fill the pool, and then all of a sudden they've got some tiles that are releasing. So highly recommended to use rapid sets on steps and on floors of swimming pools. So as I say, just for working on them. The next level is up into our reactive products. So our Kerapoxy range, so Kerapoxy adhesive, or, you know, the grouts can be used as adhesive and grout. So they're the highest strength and performing products. So highly recommended for finger grips in the commercial pools. You know, most finger grips are actually quite small, so there's a small surface area that we're trying to bond that finger grip to the structure itself. And you know, they're in areas where they suffer the most because, you know, they're pulled on and stepped on and dived off and all that type of stuff. So they really are in the harshest part of the pool. So, and of course, being an epoxy, they don't contribute to efflorescence at all. So there's no lime in them, which I'll talk about when we talk about a efflorescence-free system in a minute. So when it comes to adhesive coverage or contact, in a swimming pool, we require a minimum. So in accordance to the standards, and remember the standards are a minimum, we require a minimum of 90% contact. So the reason being is we want to have as least amount of voids behind the tile as possible. So the voids behind the tile are areas where water and air can accumulate, and that water and air can certainly expand and contract when it's either subject to heat or cold. So it just puts pressure on the system. So also excess water sitting behind the tile contributes to the efflorescence that can take place. So, you know, it says a minimum of 90%. Realistically, we would like to try and get as close to 100% as possible. So to achieve that coverage that we require, we would always use the appropriate size notch trowel. So in other words, you know, if you have got the traditional 250 by 125 pool tiles, you know, let's not use a 3 or 4 mil trowel. So, you know, if you've got tiles even in the glass mosaic range, if they are 10mm thick, step up to a 6mm trowel. So we work out the appropriate trowel size. The best way to actually look at this type of thing is spread some adhesive, push the tile into it, and pull it off and actually have a look and make sure your coverage is, you know, as what you require. Use the back trowel technique if you have got the extruded or the ridgeback tiles. They should be filled. You can see just by the way the adhesive is spread with a notch trowel, if you've got grooves on the back of the tile and they don't line up properly, then there is every chance that you'll create voids behind that tile. So if they are extruded or ridgeback tiles, they should be back butted without a doubt. When you push the tile into the adhesive, it should be worked into the adhesive to close those ridges up. So that's what it should look like when you pull the tile off. You can see with this glass tile, if you move the tile so that the adhesive should be spread in one direction, and then we move the tile across the ridges to close them up. If you move them with the ridges, you're just going to go with it. So, and if you have the adhesive spread in all sorts of directions, then which way do you actually push the tile to close up those ridges? So in most cases, it's the easiest, most efficient way to spread the adhesive is across your body, so that when you push the tile into it, you push it away from your body and pull it back, and it will close those ridges up. So we do that. We do this demonstration a lot in our schools around the country, and a lot of tilers are very, very surprised when they see this glass tile demonstration to see what what happens to adhesive when they actually bed it in there. So it's surprising how many tilers actually don't understand about bedding tiles into tile adhesive. So we'll move on into the grouts. The recommended grouts, we do recommend cementitious products. These in our standard range, so the Ceracolor range, the FF and the GG, they do contain lime. So you know, if you are looking for an efflorescence-free system, we certainly wouldn't go into using these products. In most cases, depending on the pH levels or the chemical level of the swimming pool, even when using these products, you know, efflorescence is not an issue. But if an efflorescence-free design is required, then we would certainly step up into different types of products. So when it comes to just the grout, we would go into our Ultra Color Plus. It doesn't contain lime, so it cannot contribute to the to efflorescence at all. And it comes in all 37 colours as well, where the Ceracolor only comes in 12. So the other level again with the grouts is the Cerapoxy design. Again, you know, they have the highest strength or performance levels. They can be used as adhesive and grout because it does come in 30-something colours. So if you have got, you know, like an opaque, you know, relatively see-through glass mosaic, we would recommend to use the same colour or a white or something like that that's not going to alter the end look of the mosaics. They're highly acid resistant, and again, they don't contribute to any form of efflorescence because they don't have any lime in it. So internally, externally, it doesn't make any difference. We highly recommend the use of Cerapoxy as the grout. And so you can lay in a normal traditional adhesive, but Cerapoxy as the grout when we've got spillover walls, exposed feature walls, and spars. So the spillover walls or exposed feature walls, because they're subject to that thermal expansion and contraction that's going on, there's more pressure on the system, so the epoxy adds strength. The abrasiveness of the water running over a spillover, you know, with a normal grout, it can wear it away eventually, but it won't with the epoxy. And in spars with such fluctuations and in particular hot temperatures that we're actually dealing with. So it often relates to sun exposure, so heat or the water heat itself, but we highly recommend the use of epoxy grout in those three scenarios. Into the sealants. So the silicon sealant joints or movement joints are a very, very critical part of the functionality of the pool itself. So control joints, any structural joints, as I talked about before, should be reflected up into the tile work itself. So as I said, that joint should be totally free of adhesive or any other form of rigid debris. If they are deep, they should be foam filled or foam backing rod put into the joint. The silicon should be only really at a maximum 10 mil deep. So if it's deeper than that, it should be filled up with a foam backing rod prior to adding the silicon itself. We certainly recommend our Mapei AC because it's a premium pool grade silicon. So it's 100% pure silicon. So it's available in all the colors, of course, but the reason I mentioned pool grade is because normal silicons just aren't up to the to handling the pressure or the degradation that can take place when we're dealing in that harsh environment. So the pool chemical water. So definitely always make sure you use a pool grade silicon. One thing I'll talk about with sealants or silicon joints is the fact that a lot of people overlook the importance of them. So, especially in the larger swimming pools, and I'll talk about it a bit further, but I'll just mention where movement joints should be. So just a few last things into the special topics that we talked about. So one is dealing with the negative pressure. So, pools when they're cut into the side of a hill, into areas that are governed by or, dealing with tidal water movement, that type of stuff. So when we're dealing with water that's coming from behind the pool, then it's very important to treat the junctions and the pipes for in a negative pressure. So we would step up into making sure that the construction of the pool. So in the new construction of the pool, we would use our Hydrostop, which is a swellable tape basically, or a swellable form. That's placed in, it's always put behind the steelwork, because remember, these swellable products, as I mentioned before, when they take on water, they swell to create the seal. So this is certainly powerful enough to, to blow the concrete out. So it should always be placed behind the steel, wrapped around pipes, and running alongside construction joints. So you can see in that picture there that it's placed behind the steel work, so that it's creating that seal without putting the pressure onto the face of the concrete itself. So with remediation work that we talked about before, if you have got water coming in from behind or around a pipe from underneath or from out the back of the pool or the side of the pool, we would get, again, we talked about that 60 millimetre breakout. So we break out 60 mils of the concrete, we gun in the Mapei proof swell, and then we repair with that rapid setting or the structural grout that we were talking about before. So we go with the rapid setting mainly because it can just keep the process going. So, these products dry very quickly so that we can get into and put the membrane in place. Efflorescence. Now, this is a huge topic that we deal with a lot. Those efflorescence-free systems that we talked about, they do cost extra, and a lot of people don't want to pay the extra. Quite often, we're only talking a few dollars per square metre. Most domestic pools can be anywhere between 60 and 100 square metres. You might be talking about $2 a square metre or less. It could be $1 a square metre to use a different type of adhesive, so a rapid setting or a two-part adhesive as opposed to a single-part regular setting adhesive. If you think about $1 or $2, even if it's $2 a square metre, even if it's $3 a square metre, and you've got a 100 square metre pool, $300 to reduce this type of look from taking place. So the other thing that we do is we protect the substrate itself. So people tiling, especially in domestic areas, a lot of times the membrane is not utilised. So they've got water sitting in the structure. If they have got a screed or a render, water sitting in the screed or render. So there's lime in the concrete, lime in the screed or render. There's lime in the tile adhesives and lime in the grout. There's, a very high possibility that you're going to have an efflorescence issue down the track. So if a membrane is to be used, we would certainly put it as high in the system as possible. So immediately behind the adhesive, so we at least stop the water or stop having to deal with the water and the salts that are in the render or the concrete. So the higher it up, the better it is. There's just no two ways about that. And then we would go into adhesives and grouts that don't contribute, that don't have lime as such, or they've got controlled lime situation into it. So our Granny Rapid, as I said, the two parts, the Kerabon Isolastic, Keraquick Latex Plus, Kerapoxy is the grout, and then all the Ultracolor Plus is the grout. So, we do have those systems. And as I say, quite often, if you are just using Ultracolor as opposed to Keracolor, it can be as little as cents per square metre. In most cases, the cost variation between the Ultracolor and the Keracolor is, it can be 3 times the cost. There's no doubt about that. But the reality is the cost of a grout is very cheap in the initial. Likewise with the adhesive. So the adhesive, in particular behind a glass mosaic, is, we're getting 10, 12 square metres out of a bag. So, we're not talking sheep stations here. So it's quite often, as I say, it's quite often cents or, $1, $2 or $3, even if it's $5 a square metre. $500 over a pool that's worth $60,000 or $70,000. To me, it's it's a no-brainer. It should be spent. So the efflorescence, that's the effect it can have on the grout. It alters the grout very quickly. And, realistically, that's probably the least of your problems, that when it starts dribbling down the walls, that's when it becomes very unsightly, and people kick up a fuss about it, of course, as they should. So on movement joints, as I said, I was going to touch on where we place them and how we place them. They are there for a reason, as I said, and in accordance to the standard, they should be incorporated in a pool. They should be at the perimeter. So if it is a square edge swimming pool, it should be at the wall floor junction. It should be at the wall junction. Different with a lot of the sprayed pools, because they're rounded off. Then it's not really a junction as such. In particular, the joint that's forgotten the most is between the pool tile and the coping tile. So that's more often than not, it's grouted, and people wonder why they have waterline tiles bulging and coming off the wall, or they have their coping tiles that are gone drummy and detached. A perfect example is a swimming pool that sits in on a 35-degree day or a 30-degree day, and it's got a nice black or stone coping tile around it that's sitting up there at anywhere between 50 degrees or greater. And then the kids come home from school, jump into the pool, the splash comes out, hits those the coping tiles. There's that, or even the water that's lapping up onto the tiles that are above the water level. There's a rapid thermal change, or rapid temperature change in those areas. So that thermal movement takes place rapidly. So it's thermal shock can take place. And or just the difference of the constant temperature in the pool, and then the variation of the temperature of the stone or the tile in the surround or above the waterline, as I said. So if the grout joints are less than 5 millimetres, then the intervals for movement joints should be around 6 metres or less. In the coping tiles, it should be at 3 metre intervals. In a dark coloured situation, I would even recommend them to come into around 2 metres. So after the installation, a lot of things that we deal with is aggressive cleaning. So aggressive cleaning can be in two different ways. So it can be high pressure water blasting the pool immediately after the grouting's finished, or the day after the grouting's finished. Especially if you're using regular setting products, the pool should be left to stand for those products to cure, to get to their maximum strength before we start hitting them with high pressured water, or hitting them with water in particular. So pools really should be tiled with a canopy over the top, so they're protected from the environment whilst everything's actually drying, because as I say, their life is going to be in a harsh environment, so they should be protected. The other thing that happens, the other concept to aggressive cleaning is the use of aggressive acids. So high strength acids like hydrochloric acid, spirits of salt. So you're not only are you causing degradation of the grout and possibly the adhesive and possibly the membrane as the acid goes further into the system, but you're also adding salt into the system as well. So a lot of people go to the trouble of using certain aspects of the efflorescence-free system, but then they go and wash it with an aggressive acid or hydrochloric acid or spirits of salt, and they put salt back into the system. So, but the reality is, as I say, people often say to me, "Oh, I use it at 10 to 1 or 20 to 1, and then I dilute it by washing it all off." But the reality is, in most cases, you're applying the acid to a porous surface or a porous product. So the grout in most cases is porous. The adhesive is porous. So by the time they've washed 5, 6, 10 square meters and then come back and dilute it by washing it off, that acid has already soaked into the grout and possibly got to the adhesive and possibly got to the membrane. So avoid using hydrochloric acid, full stop, as far as what I'm concerned. So we have specific cleaners. We have products like Keranet or Kerapoxy cleaner, phosphoric acid, as simple as using powders that you use in a dishwashing machine. They've got a light phosphoric acid in it. The powder has got a bit of scarification. Elbow grease with a scouring pad or a scrubbing brush if it's required. You don't need to use chemicals that are going to remove everything. We know it's easier. You don't have to use that elbow grease, but it's causing problems with the system itself. So the other thing is avoiding the filling time too early. So as I said, even when it comes to cleaning, a lot of times the cleaning's done and the bottom of the pool's already got 5 inches of water into it. So avoid that. We want to, as I say, leave it empty for minimum of 4 days, but even up to 21 days. So it's even stated in the Australian standards itself to actually let the pool sit for a few weeks before you go filling it. So filling it should be controlled, so the levels are risen. Well, it says 750 mil every day. Most people fill them 24 hours or 8 hours and the pool's full. So it puts the whole system back under pressure again. And likewise, when it comes to heating the pool, we heat it at a slow rate for the first time. Once it's done that thermal movement, then it's no big deal. It's like having heating in your floor, in your bathroom floor or something like that. When you heat it for the first time, you heat it gradually just so you don't get that thermal shock that's going to take place. This is just a little look at what acids do to grouts. That's a blob of grout basically. So you can see when it's painted onto it, it starts eating it away straight away. So, and you can also see how fast it soaks into the grout. So it's a liquid, so onto something porous. So it's going to be drawn into the grout, and as I say, that damage is not only going to occur on the surface, but it's going to weaken the integrity of the whole grout joint. So in particular, when we've got narrow or not so deep, shallow grout joints, mosaics, a lot of the time they're 3 mil deep or 3 mil thick, and you might have 1 millimeter adhesive of adhesive already up into that grout joint. So you might have 2 millimeter grout cover, and then you go and hit it with acids. It can be will be problematic. There's no doubt about that. We often have people ring us up and say, "Oh, my grout started off as grey and now it's light grey. Why? You know, the first thing I say to them, what did you wash it with? You know, so yeah, just avoid the aggressive cleaning. Allow for cure times. It's really important thing to allow for that cure time to take place. So the resources that we've got available to everyone on our website is our work method statements. So they've got the pretty pictures and also the step-by-step guide. So we talk about everything from substrate preparation right through to the finish of the movement joints in those work method statements. A really handy resource. As I say, they're available for free on the website. You know, it's a good thing. We try and teach contractors to use these things when they are pricing. So, you know, when you give someone your price, you can hand them a work method statement with it. We can even customize these into a short form specification. So it enables you to justify that you're more expensive than Joe Blow because this is the system that I use. You know, in that system, it talks about good, better, best products. And you can actually say, well, I use the best products in, you know, the whole way through my system. So that's why I'm $5 or $10 or $50 a metre more expensive than what Joe down the road is. So, you know, we teach people about doing two-tiered prices. We even talk to builders about accepting two-tiered prices. So giving the client the option to say, okay, well, yeah, I'm happy to accept Joe's price, but I would prefer Johnny's price because he does use these products. So we give them the options of selecting, for instance, an efflorescence-free system. You know, selecting epoxy grout as opposed to cementitious grout. So, you know, it's not a shock to the installer when he gets told, oh, hang on, I want epoxy grout, and they say, well, I haven't allowed for it, you know. So they're a really good, not only are they a good source of information, but they're a good way to make yourself look good. So as I said, that's the addresses of the Academy and our website. There are those other webinars that I mentioned on these sites. So, you know, we've got everything from efflorescence to cladding to adhesive types, balcony, waterproofing and so on. They're all on there. So the ones that we've already done, you can just replay them at your leisure. My details are there. You can certainly, if you can't put a question on or you don't want to put a question on today, that's all fine by me, but you can certainly email me at any stage and come through with any questions that you got, or if you've got any particular applications that you feel are difficult, then certainly come to us with the, you know, with all your information, and we'll put together a specification, or we'll put together a you know, a form of recommendations to cover your scenario. So thank you very much. I hope you got something out of it. I can't see any questions there, so I'm going to move on. But yeah, as I say, thanks for your time, and if you've got anything that you need down the track, feel free to get in touch with myself or with Mapei via our website. Thanks for your attention.
We've got a couple of questions here.
Ooh, okay.
Just a couple of questions. One,
Yep.
Can you discuss the best system, so render, waterproofing, adhesive, etc., for an above ground tiled pool, mainly regards to stopping calcium?
Okay, for certain. So, so definitely, it doesn't matter if it's above ground or not. If you are talking about the efflorescence on the inside, or if you're talking about the efflorescence on the outside, it doesn't really make any difference, because what can reduce that efflorescence is by using the waterproofing membrane above your render or onto your concrete. And if it is above ground pool, then I highly recommend the membrane goes up and over the top of the shell and down on the outside. So we're basically encapsulating the whole concrete structure and or render along with it. Then for the efflorescence-free adhesives, as I said, it's best to go into the two-part products. So either Kerabond with Isolastic as a regular setting product, the Granny Rapid or the Kera Quick mixed with latex plus as a rapid setting. So we would go into those particular products that have a much less effect on or any contribution to the efflorescence itself. Mainly the reason is because the latex component encapsulates or basically wraps up, has the ability to wrap up the cement in a better way. The Granny Rapid itself is a different type of cement, so it doesn't contain any lime. And or we can step up into the epoxy. But there is, when I talk about the differences of the price of adhesives, there is a big jump from going from a cementitious base to an epoxy base. So, you know, that is into the tens per square metre. But yeah, the two-part adhesives are far greater for the reduction or the elimination of efflorescence. And then as a minimum, the ultracolour grout, again, it doesn't contain the lime, so you cannot get efflorescence from it. And or the next level would be the Care Epoxy grout itself again. So that's a complete efflorescence-free system.
We've got another question. Is it better to have a drier or wetter grout for the installation?
Okay, that's a very good question. Something we battle a lot, and in fact, if you go onto the website and you look up the webinars that we've completed, one of them is on grout, and it talks about the importance of mixing grout correctly. So my recommendations on that is grout is one of very few products, but certainly I believe one of the most important products to measure your water. So if you're an installer, go and buy yourself a $2 jug that's got the measurements on the side of it, and literally measure out your water in accordance to the data sheet. Again, what I said before, those products are developed by guys that are a lot smarter than you and me, but what they do is they develop that formulation to work with a certain amount of water. So it's certainly recommended. So it's not a matter of having it wetter or drier, it's a matter of having it mixed with the correct amount of water. And the other thing that assists greatly is mixing the grout twice. So have the correct amount of water, add your powder, mix it once, then step back, let it sit for 3 or 4 minutes, and then come back and just give it another quick mix. So it might only be a minute or two for the secondary mix, but that not only does it make the product blend properly, so you're going to get a much more even colour when you dry, but it's also going to increase the open time, so the amount of time you've got to work with the grout, and it also increases the workability of the product itself. So it makes it much nicer to actually work with. So in answer to your question, wetter or drier is not really, it's not really, hasn't got a place. It should be mixed correctly. So as I say, go buy yourself a jug and measure out your water. So, I've been around tiling I did my apprenticeship 37 years ago, and I always, and I had a lot of guys working for me over the years, and I always highly stress that they have that jug and they measure out. As I say, if you don't measure it out for your glue, you don't measure it out for your screed or render or your patching compounds, any of that, it's almost, by the by. But when it comes to grout, measure your water. It's very, very important, and mix it twice.
So we've got one more.
Sure.
And it's a bit of a two-parter. The first part of it is, would you use Mapei Pronto for the screed on the walls as well? And the second part is, you answer that one.
Yeah, so the answer is no. The reason being is the makeup of the screed blend, so the Mapei Pronto and the Top Pronto. I say no, it does get used. I have been onto plenty of jobs where I see them rendering up with Mapei Pronto and Top Pronto for that matter, but they are designed as a screed. So when they are mixed into the correct ratio, they want a slump. So they don't have what we call a thixotropic nature. So they don't hang. So they're designed to be on a floor. So really the best thing to render up a wall is a render product. So like the smooth and repair that we talked about, or I think that's probably the best. We do have others, but I think that's probably the best one to use. It acts like a render should do. So it actually has got that fixotropic, or the ability to hang. So it will actually stay on the wall without slumping down and falling onto the floor anyway. So while it can be used, I don't recommend it. It's the other thing about it, it does need a slurry to bond, and to use Mapei Chem, because it's a rapid setting product, you need a rapid setting slurry. So a lot of the time, by the time you put your slurry on and then you go and try and trowel, even if you've got a hawk and you're pushing the Mapei Chem onto the wall, your slurry's already dried and you've basically got a layer of detachment that's already there. So I would highly recommend that, a bit of moisture, and then using the smooth and repair, the plain top smooth and repair, much better. A much better way to go. There's just no two ways about it. Second part.
Second part was, which is best, Top Chem or Mapei Chem Pronto?
Okay, well, there's different properties of the product. So obviously, Mapei Chem is a rapid setting product. So in other words, you could screed your floor, and literally 4 hours later, you can be walking on it and putting your membrane on it, starting to tile, whatever you want to do. It's fast drying, and it does dry at a higher MPa. So it does dry it up around that 50 MPa, where the Top Chem Pronto is a slow drying or a regular drying product. And so you would screed today and come back tomorrow. You wouldn't want to do it, you can't do it in the same day. And it doesn't dry as strong, so it's down around the 25 or up to 30 MPa after X amount of time. So there is a difference in the strength, but there's also a difference in the drying time. So it's really horses for courses. If you want a rapid setting, rock hard base, then you would go with the Mapei Chem Pronto. If you're just happy to do a normal setting, with still a rock hard base, because remembering most concrete's around 25 MPa, so we're at that type of strength anyway. So really the strength's kind of neither here nor there when it comes to render or screeding a swimming pool, because we're not driving trucks on it. We shouldn't be driving trucks on it. So, it depends if you want the fast setting or the slow setting. That's really all it is.
That's all of the questions.
That's it. All righty. Well, thank you for the time, and thank you for the questions. And as I say, you can always get in touch with us at a later date via the website or email. Good luck. See you all next time. Thanks, Katie.